Let me ask you something. If you needed 10 EC2 instances, would you really create 10 resource blocks? Thankfully, Terraform has a much better way. Meet Terraform's count meta argument. When Terraform says count equals 4, it creates the first EC2 instance, then the second, then the third, and finally the fourth, all from a single resource block. Now let's start with the tutorial and try to understand what our configuration has. So if you look at this configuration, what it creates is it creates a VPC and basically subnets, and each subnet has got its own each private subnet has got its own EC2 instance. So you see that there is an AWS instance app A, which is tied on to the private subnet one subnet ID, and if you see that there is another instance which is associated with the second subnet. Now let's look at the variables and see what are the we have public subnets, two public subnets and two private subnets, and VPC side of block, and we have all of these public subnet side of blocks, and we have the private subnet side of blocks. Okay, default equal, there are a lot of them, right? That's fine. Now let's go to your let's try to initialize. This will take a while. So Terraform init has worked. Now let's do a Terraform apply. This will take some time too. So now it has completed applying and it has created the VPC, the private subnets, and basically the instances that belong to each private subnet, right? Now, if you look at the variables, the number of subnets per private subnets per VPC is 2. And so you have those two VPs, two subnets that will be created for your VPC from those list, the default list that we have in from here. And then each of the instance, if you see, we have an app in AWS instance app A, and then there is another AWS instance app B that were created. But then if you look at the subnet ID, the subnet ID is actually hard coded to the VPC private subnet 0, and then the one which is the first and the second subnet, right? Now let's say I want to increase the number of private subnets per VPC from 2 to 3, then this will not scale, because these instances, they are basically two separate resource blocks, and they are hard coded to each subnet. It is the first and second. So when a third private subnet is added, it doesn't know where to get the subnet from, and this solution basically will not scale if you want to increase your subnet ID. That's where our count comes into picture, and using count we can refactor this EC2 configuration. So let's try to get rid of this second resource block, and we will basically call the app A instance as just A, which is now generic. And now instead of we'll declare a variable instances per subnet. Again, this tutorial is available, the link will be available in our description. If you want to follow along, I would suggest you to actually do it, because you would think that you can learn from watching, but you will only understand it when you do it. So highly recommend doing the tutorial yourself. So I have added the instances per subnet. So if you see here now, we earlier didn't only have like one instance, right? Now we have increased that to instances. Where's my instances per subnet? Yeah, I've added it here. We are increasing the number of EC2 instances. Earlier was 1 to 2, and let's see how we can incorporate in our resource configuration. So we use scale, subnet ID. First of all, we have to declare the count. So how many EC2 instances will be created? So if the number of private subnets are 4, and the number of instances per subnet is 2, so basically 4, right? And so it is var dot instances per subnet, yes, and var dot we can also use length module private VPC subnets. Basically number of subnets are 2. When you do a length is a function we watched in the last tutorial. Basically 4. Our count will be 2 into 2, that will be 4. Now how will you get the subnet ID? The autocorrect has already recommended the suggestion. So if you look at it, the subnet ID is we're not going to use floor, going to use, okay, I don't know what floor is, but yeah, this sounds, there is a modulo function that actually gets the right. So if you have, let's just let me just explain, right? If you have, we start with count.index is nothing but the number of indices in your count. So in this case we have 2 subnets and 2 instances per subnet, so it will be 0 1 2 3. So your 0% 2 will be 0 and 1% 2 will be 1, and 2% 2 modulo 2 will be 0 and 3 modulo 2 will be 1. So it'll be 0 1 and 0 1. So basically each subnet, it'll just alternate between the subnets, which will take care of associating the instances correctly to both of the subnets. Now this is the instance part and the association with the subnet that is already done. Now we also have a load balancer, right, which was also again sort of hard coded. Now we will have to update it in a way that it will be number of instances is not 2, it will be length. We don't have to do ID, we just have to do just length. That will be 2. Number of instances will be 4 actually. Length of 8, because there will be 4 instances that will be completely created, and the actual instances is we can use I remember I have used the star before, yeah. So if it is the AWS instance dot app, and then you can use your star dot star. So what dot star does is that it basically iterates each instance of it in a particular list. For example, AWS underscore instance dot app has got 4 instances, right? It'll go through each of this, which is 0 1 2 3, and then it gets the ID of it and then passes it. So in your load balancer, the number of instances associated with the load balancer will again be 4. Now this will scale for how many ever instances. In this case we have 4 instances, but it can scale for any instances or any number of subnets that you are basically going to, if your solution, if your project gets bigger and there's more infrastructure, you can basically scale it the way you want it, all just by using the count, which is amazing, right? And you're not really doing anything, you're not doing much, and we will try to output all the new instances, basically all of the instances by we already have instances. Again, this is hard coded, we will change that into AWS underscore app, which is again suggestion is given. And now we will do Terraform apply again. Terraform has now finished applying, and now we can see that in the output it has printed all the new instances where the count has now increased to 4, and it has added 8 instances. Basically it destroyed the previous ones, and it has created the new instances and attached each of these instances. Basically they are associated, they are created in different private subnets, increasing the number of instances per subnet from 1 to 2. This is how you can scale your EC2 instances, or basically anything using the count and count.index. And that's Terraform Count. We took multiple hard-coded EC2 resources and transferred them into a scalable configuration using a single resource block. Along the way, we learned how count works, how count.index helps identify resources, and how Terraform distributes instances across subnets automatically. If you found this tutorial helpful, consider liking this video and subscribing for more Terraform and cloud engineering content. Thanks for watching, and I'll see you in the next video.